Imagine for a second that you were standing right in the center of a massive enterprise data center. You're staring at these long rows of incredibly expensive, highly capable server hardware.
Right. The really heavy-duty stuff.
Exactly. But at this exact moment, they're completely isolated. It's basically just a static, chaotic pile of compute power, raw storage, and like tangles of network cables.
Yeah, just a very expensive space heater at that point.
Seriously. So how do you take that disconnected pile of metal and fundamentally transform it into a single, unified, resilient cloud ecosystem?
Well, I mean, that's the ultimate architectural challenge, isn't it? Because bare metal without any sort of orchestration is, well, it's just a massive electricity bill.
Right.
The physical servers can run the workload, sure, but they have absolutely no awareness of each other. There's no shared strategy and, no way to automatically recover if a component just randomly fails.
Which brings us perfectly to the mission of today's deep dive. We are doing a comprehensive exploration of VMware's vCenter. And we've got a whole stack of sources today: architectural blueprints, deployment guides, some pretty intense security case studies, and inventory best practices.
Yeah, some really dense material in there.
Oh, for sure. But we're going to break it down. We're dissecting the core architecture, the deployment mechanics, the modern identity security landscape, and just the day-to-day inventory management of this software.
And the goal here is that by the end of this, you are going to have basically the ultimate architect's blueprint for mastering virtual infrastructure.
Exactly.
Because the core theme running through all these documents is that vCenter is not, it's not merely an administrative dashboard that you just, check on Friday afternoons.
Right. It's not just a status screen.
Exactly. It is the strategic nerve center. It totally dictates the scalability, the security boundaries, and frankly, the literal survival of the entire enterprise environment when it's under heavy load.
Okay, let's unpack this architecture because I think we need to ground this. If we go back to that room full of servers, we are essentially talking about ESXi hosts.
Right, the foundational layer.
Yeah. And just for anyone maybe new to the strict terminology, ESXi is the bare metal hypervisor. It gets installed directly onto the physical hardware, and it actually runs the virtual machines. But like we said, the ESXi don't coordinate with each other natively.
No, they're basically islands.
Right. So the orchestrator that brings them together is the vCenter Server Appliance, or the VCSA as it's usually called.
Yeah, and the VCSA is this brilliant all-in-one appliance model. It runs on a hardened Linux operating system called Photon OS.
Photon OS, that's VMware's own build, right?
Yep, purpose-built by VMware. They made it to be as lightweight and secure as mathematically possible. And inside that Photon OS shell, it uses an embedded PostgreSQL database to basically store every single configuration, every event, and all the performance metrics.
Which is a ton of data.
Oh, it's massive. But what's really fascinating here is the sheer amount of consolidation they've pulled off. The modern VCSA bundles the vSphere client, the central license service, the content library for your templates, and even the vSphere lifecycle manager, all of it into a single virtual machine package.
Okay, wait. I look at that consolidation, and I immediately just see a massive single point of failure.
Oh, I know where you're going with this.
I mean, if everything, the database, the client, the lifecycle manager, if it all lives inside one single appliance, what happens when that appliance gets corrupted or, just goes offline? Do you suddenly lose control of 40,000 virtual machines? Do they just crash?
So that is a huge architectural misconception. The workloads absolutely do not crash.
Oh, really?
Yeah, because remember, the ESXi hosts themselves are the ones actually running the virtual machines. If you unplug the vCenter appliance entirely, the underlying ESXi hosts just keep running their existing workloads perfectly fine.
Wow. Okay, so the data plane stays up.
Exactly. What you lose is the orchestration layer. So, you lose the ability to deploy brand new VMs, and you lose the dynamic features like vSphere DRS, the distributed resource scheduler.
Got it.
But to protect the appliance itself from going down, enterprises utilize vCenter high availability. It essentially clones the VCSA into an active, passive, and witness node cluster. So if the active node literally catches on fire, the passive node takes over the management IP in a matter of minutes.
That's incredible. And I want to dig into those dynamic features you just mentioned, actually, because the sources constantly use the word resilient.
It's their favorite buzzword. Yeah.
Right.
Yeah.
So we know vCenter provides high availability, or HA, and vMotion. But from a purely mechanical standpoint, how is this management appliance actually preventing downtime?
It really all comes down to continuous telemetry and dynamic resource allocation. With vSphere HA, vCenter configures the ESXi hosts to constantly send these network heartbeats to each other.
Like a pulse check.
Exactly. So if a physical server suddenly, loses a power supply and dies, those heartbeats just stop. Okay. The surviving hosts in the cluster instantly detect the failure. They check the shared storage logs to make sure the VMs aren't running anywhere else. And then they instantly reboot those crashed virtual machines onto their own healthy hardware.
That is so fast. And vMotion is even more impressive to me because there isn't even a reboot involved.
Yeah, vMotion is basically magic.
It really is. If I am looking at the telemetry and I see a host running at like 99% CPU, vMotion lets vCenter seamlessly migrate those live workloads from the burdened server over to a quiet one without dropping a single user session.
None. Zero downtime.
The mechanism behind that is just wild because vCenter isn't moving the physical hard drive files, right? The shared storage stays exactly where it is.
Right. The data doesn't move.
It is actively copying the live memory state of the virtual machine across a dedicated network to the destination host. It tracks the change memory pages in real time and then just does this microsecond cutover.
And to coordinate millions of memory pages transferring across a network like that, your initial setup has to be flawless. I mean, absolutely perfect.
Right, which brings us to the deployment side of things.
Yeah, because the deployment guides really stress that selecting the correct appliance size and database storage up front is a massive strategic consideration. I mean, the PostgreSQL database has to process and retain all of that telemetry we just talked about.
So if you skimp on the specs...
Oh, if you undersize the appliance compute or storage, it will physically bottleneck. It will just choke trying to write all those metrics to disk.
Yeah, and the scale we are talking about with vCenter 8.0 is pretty staggering. Let me just pull these numbers up. A single instance can manage 2,500 ESXi hosts, support 40,000 powered-on virtual machines, and you can pack up to 96 physical hosts into a single cluster.
It's massive.
I honestly struggle with the plumbing of that scale. I mean, if I have a cluster of 96 physical enterprise servers, how does one single appliance push commands to all of them without completely saturating the management network or just melting its own CPU?
Well, it avoids that by utilizing a really highly optimized layered agent architecture. It doesn't rely on brute force remote procedure calls.
Okay, so how does it talk to them?
When you add an ESXi host to vCenter, the appliance installs this tiny localized agent called VPXA directly onto the host.
Okay, VPXA.
Right, and that vSXA agent acts as a dedicated liaison. Up in the vCenter appliance, there's a core service running called VPXD, and the VPXD service only ever talks to the VPX agent.
Oh, I see. So the appliance talks to the agent, and then the agent is the one that translates that command for the physical server itself.
Exactly. The VPX agent receives the orchestration commands from above and then relays them locally to a service called the host daemon.
Hosted, right?
Yeah, host is basically the actual brain of the ESXi host. It manages the local storage, the network switches, and the VM power states.
So it's a chain of command.
Very clean, very low latency.
Huh?
VPXD in the appliance talks down to VPXA on the host, which then commands host. It is effectively a central nervous system for the data center.
It's brilliant. But, understanding that nervous system on paper is one thing. Actually giving birth to it is another challenge entirely.
Oh, absolutely. Deploying it is a whole thing.
Yeah, because the deployment guides outline a very specific two-stage process for getting this control center up and running. And I have to admit, in a world where we kind of expect a simple, next finish installer, breaking this into two distinct hard stop stages feels incredibly antiquated to me.
It definitely feels slow when you're doing it, but the separation is strategically necessary to prevent catastrophic deployment failures.
Really? How so?
Well, stage one is just the physical deployment of the OVF template, the open virtualization format. During this stage, you are purely interacting with the underlying hypervisor.
Okay, just the basics.
Right. You are passing a manifest file that basically says, hey, I need a virtual machine carved out with this specific CPU count, this exact storage allocation, and this basic network IP address. You are just establishing the physical footprint and getting the Photon OS to power on.
So you're basically pouring the concrete and building the house, and then stage two is turning on the utilities inside.
That's a great analogy. Stage two is entirely about identity and configuration. The installer connects to that IP address you just established and configures the single sign-on domain, the internal certificate authority, and the customer experience improvement program, the CEIP.
Right, the telemetry stuff.
Yeah. But the absolute most critical setting in stage two, and this is the one that will absolutely destroy an environment if you overlook it, is time synchronization via NTP.
Network time protocol. Yes, the sources were practically screaming about this. If you are listening to this right now and wondering why your vSphere client keeps throwing random certificate errors or, why your hosts just keep briefly disconnecting for no reason, it almost always points back to a broken NTP configuration.
Always. Because in a distributed system, time synchronization is literally the absolute foundation of cryptographic trust. When vCenter issues a security token to a user or a host, that token has a strict mathematical validity window. So if the vCenter appliance and the ESXi hosts have internal clocks that are out of sync by even like a few minutes, the host will look at the token and view it as either expired or arriving from the future.
And it just rejects it.
Boom! Authentication fails, certificates become instantly invalid, and furthermore, if you experience a security breach, your system log files are completely useless for forensic analysis because the timelines of events across the different servers just don't line up. You can't track the attacker.
Which is terrifying. And that actually leads us directly into another massive administrative pitfall that also involves a ticking clock, and that is licensing.
Oh yeah, the licensing trap.
The notes came with this huge warning label about the default 60-day evaluation mode. Basically, when you first finish stage 2 and log in, vSphere just hands you 60 days where every single enterprise feature is fully unlocked.
Which is generous, but dangerous.
Right. It is incredibly easy to just start building your clusters and completely forget that countdown has actually started in the background.
And the reason administrators get caught by this is because the licensing workflow is a very deliberate two-step process. You can't just paste a license key into a prompt on day 1 and walk away.
So what's step 1?
Step 1 requires you to actually add your 25-character license keys into the central license service repository within vCenter. So you're basically just stocking the vault.
Just putting the keys in a drawer.
Yeah.
But the software doesn't automatically know what those keys are meant for.
Exactly. Step 2 is you have to manually assign those keys to specific assets in your inventory. So your vCenter instance itself, your individual ESXi hosts, or your vSAN storage clusters.
And if you forget step 2,
if you just stock the vault and forget to assign them, day 60 arrives, and the license service hard restricts the API. Yeah, the environment enters a highly restricted state. You can no longer power on virtual machines, you cannot modify configurations, and in many cases, your ESXi host will just logically disconnect from vCenter entirely. It causes massive, immediate administrative paralysis.
it is a brutal, brutal lesson in inventory management. And just quickly, the sources do briefly detail the tiers of those licenses. You have the Essential and Plus kits, which are hard capped at 3 hosts. And those are really designed purely for small business footprint consolidation.
Right, very basic setups.
But if you want the dynamic resilience we were geeking out about earlier, vSphere HA, vMotion, fault tolerance, VM encryption, you are forced into the Standard or Enterprise Plus tiers.
Because at that tier, the goal is no longer just basic virtualization. You are architecting a fully private, highly resilient cloud infrastructure.
Okay, so let's say you've done it. You've built the infrastructure, you've configured the NTP timestamp perfectly, you assign the enterprise licenses, and the environment is just humming along.
Sounds great.
It does. But the terrifying reality is that a fully operational vCenter is literally the keys to the kingdom. If an attacker manages to bypass your perimeter endpoint defenses, this appliance is the very first thing they look for.
Oh, without a doubt. And the documentation actually highlights a really chilling case study regarding this exact scenario. It goes into the 2022 VMware Identity Manager exploits, specifically CVE-2022-22994 and 22960.
Yeah, those numbers haunt a lot of admins.
Seriously. Advanced persistent threat groups basically chained these vulnerabilities together to utterly compromise enterprise environments, and they did it without even triggering standard endpoint detection and response tools.
Here's where it gets really interesting. Let's break down the mechanics of that chain, because the first vulnerability was a server-side template injection, right?
Yeah, and that template injection allowed for remote code execution. So because the input validation in the software was flawed, an external attacker could send a maliciously crafted HTTP request, and the server would actually execute it as a local command.
Which is bad enough.
Right. But that command executed with very low privileges. So to do real structural damage, they chained it with the second vulnerability, which was a local privilege escalation flaw within the identity management layer itself.
So they get a foot in the door with the low privileges from the first flaw, and then they use the second flaw to immediately escalate themselves to root access.
You got it.
And because they compromise the identity appliance itself, They were able to spawn backdoors and basically deploy ransomware using legitimate, trusted system processes, like they used Tomcat executables to deploy the malware.
Exactly. And that's why the endpoint security tools completely ignored the malicious activity. Because, from the antivirus's perspective, the highly trusted Tomcat server was simply executing a standard script.
It looked totally normal to the security software.
It did. And this exploit perfectly highlights a fundamental failure in legacy security paradigms. If an attacker can steal a password or hijack a session token, the system just blindly trusts them.
Because a password only proves possession of a string of characters.
Exactly. It provides zero cryptographic proof of the actual human identity sitting at the keyboard.
Which really necessitates the entire shift away from local passwords and toward modern identity, credential, and access management, or ICAM frameworks.
It's mandatory at this point.
Yeah. The sources detail how vCenter addresses this by basically deprecating local authentication in favor of integrating directly with federated identity providers.
Right. So instead of vCenter checking its own local database for your password, it acts as a service provider that relies on an external identity provider, like, say, Active Directory Federation Services.
So how does the login flow actually work then?
When you attempt to log in, vCenter just immediately redirects you. The identity provider authenticates you on their end, and if you pass, it issues a SAML token back to vCenter.
And for those unfamiliar with the underlying crypto there, a SAML token is essentially an XML-based assertion that is cryptographically signed by the identity provider's private key. And then vCenter uses the corresponding public key to validate that the token is authentic and absolutely hasn't been tampered with in transit.
Exactly. And by offloading the authentication to a modern identity provider, the enterprise can enforce true zero-trust principles.
Meaning they can enforce more than just a password.
Oh, way more. The identity provider can require multi-factor authentication, it can demand hardware security keys like a YubiKey, and most importantly, it can demand biometric verification like a fingerprint scan or facial recognition.
Which solves the possession problem.
Right. The system verifies the actual biometric identity of the human, and it analyzes the security posture of the physical laptop they're using before it ever generates that SAML token. The zero-trust philosophy is enforced before the user even reaches the vCenter login prompt.
Okay, so you have securely locked the front door with biometric-backed, cryptographically signed SAML tokens. You have a secure fortress. Well, not quite. Because security doesn't mean much if the environment is so convoluted that the administrative team can't actually use it. I mean, if you have 40,000 virtual machines in an Enterprise Plus environment, how do you manage that inventory on a daily basis without just drowning in the user interface?
Yeah, you will absolutely drown if you don't use strict logical organization.
So how do they do it?
Well, the vSphere client, which you access via your web browser on port 443, offers a few different organizational perspectives. When you click the main menu, the little hamburger icon, you generally operate in two distinct views.
Okay.
The hosts and clusters view is where you manage the physical compute boundaries. So this is where you organize the physical ESXi hosts, manage the shared storage data stores, and configure the high availability failover settings we talked about.
It's basically like organizing the kitchen appliances. You're managing the underlying hardware engine.
That's a good way to look at it. But then you have the VMs and templates view, which abstracts the physical metal entirely.
Right. You don't care about the hardware there.
Not at all. That view lets you focus purely on the logical workloads. So you're organizing the virtual machines, applying guest OS customization specs, and managing the lifecycle of your application servers.
But even within those views, how do you stop inventory sprawl?
Well, architects rely heavily on data center objects and folder structures. A data center object in vSphere is a strict logical boundary.
So an object in one data center can't easily, share resources or vMotion to a host in a completely different data center object.
Generally, no. You establish them to create hard fault domains, so you're often mapping them to geographic locations, like you'll have a New York data center and a London data center.
Okay, that makes sense. And then within those data centers, you utilize folders, but the notes make it really clear that folders are not just there to make the inventory tree look tidy.
Oh, no, they are heavily functional.
Right. Like you might create a folder for data servers or a folder for a specific department.
Yeah.
But the real mechanism here is that folders actually act as boundaries for micro-segmentation and role-based access control.
Yes. Returning to our zero-trust principles, you never, ever grant sweeping global administrator privileges to an IT staff member.
Too dangerous.
Way too dangerous. Instead, you use folders, along with custom tags and attributes, to enforce least privilege access.
How does that look in practice?
So you could tag a specific cluster of VMs as highly confidential finance. Then you apply a strict permission role directly to that folder, and you ensure that only the verified finance administrators can even see those virtual machines in their client view. Everyone else just sees an empty folder or they don't see it at all.
That level of granular control is amazing. Now, I do want to clarify one highly technical detail from the deployment notes that really caught my attention. We just mentioned accessing the vSphere client on port 443 to manage the infrastructure.
Yep, the standard HTTPS port.
Right. But there is a huge emphasis in the guides placed on port 5480. What is the functional difference between the regular vSphere client and this management interface on port 5480?
Great question. Port 5480 accesses the vCenter Appliance Management Interface, which everyone just calls a VMI.
The VMI.
Okay. Yeah. You use port 443 to manage the data center workloads. You use port 5480 to manage the VCSA appliance itself.
So it's the control panel for the control panel.
Exactly. The VMI is where you configure file-based backups of that internal PostgreSQL database. It's where you install VMware patch updates directly to the Photon OS, and it's where you manage the appliance networking.
And the networking aspect is critical, right?
Yeah.
Because the VMI actually allows you to multi-home the appliance.
It does.
Meaning you aren't just stuck with one single network interface card. You can assign up to 4 virtual NICs to the vCenter appliance to strictly segment your traffic.
Which is a huge best practice.
Yeah. You can put your management UI traffic on one subnet, your vCenter HA heartbeat traffic on a completely different subnet, and your appliance backup traffic on a third. It totally isolates the traffic streams, which actively prevents network saturation if you kick off a massive database backup in the middle of the day.
It's all about keeping the control plane stable. And, we've scaled from the internal database all the way up to multi-homing the appliance. But for truly global enterprises, the ultimate architectural goal discussed in the sources is Enhanced Linked Mode, or ELM.
ELM. So if a single vCenter manages 40,000 VMs, ELM is essentially how you manage multiple vCenters without completely losing your mind.
Pretty much. Enhanced Linked Mode connects multiple vCenter server instances together into a single SSO domain. It basically functions like a franchise management model.
I like that.
Yeah, you do not need to log into the New York vCenter, do some work, log out, and then log into the Tokyo vCenter to deploy workloads over there. With ELM, you authenticate once with your biometric SAML token, and the system replicates your roles, your permissions, and all those custom tags across up to 15 linked vCenter instances globally.
Wait, 15 instances linked together?
Yep.
That is, let me do the math. That is up to 600,000 virtual machines manageable from a single pane of glass with seamless inventory search across continents.
It's wild.
That is the absolute definition of operational efficiency at scale.
It really is.
So what does this all mean for you as an architect? We started this deep dive by looking at an isolated, chaotic room full of raw physical hardware.
The space eaters.
Right. But what the blueprints show us is that vCenter is so much more than just a dashboard. When you carefully size the architecture, when you respect the deployment configurations, like keeping your NTP times strictly in sync, and when you lock down authentication behind federated biometrics and strategically organize your tags, you effectively orchestrate that raw compute power into an intelligent, highly resilient private cloud.
And, as we look to the future of managing that private cloud, the sheer scale we just discussed, hundreds of thousands of VMs, leaves us with a really fascinating architectural paradox to consider.
What was that?
Well, we spend a lot of time analyzing how to secure this infrastructure by tying access directly to a human being's biometric signature, right?
Fingerprints, facial recognition.
But at global scale, human beings are frankly too slow to manage the daily provisioning. We increasingly rely on automated AI agents, infrastructure as code pipelines, and API scripts to manage the environment for us.
Right. The scripts are making the API calls, not the humans typing on keyboard.
Exactly. Which poses a massive challenge for the zero trust model. Because how do you apply the absolute certainty of biometric level identity verification to a piece of Python code?
Oh, wow. Yeah.
When an automated AI agent requests a SAML token to deploy 100 servers across an enhanced linked mode environment, how do we cryptographically prove that the script is actually who it claims to be and hasn't been quietly compromised by a vulnerability like that template injection we saw back in 2022?
That is a deeply complex identity problem to leave you pondering.
Yeah.
Because code doesn't have a fingerprint.
It sure doesn't.
Well, thank you for joining us on this deep dive into the virtualized data center. We really hope you take these architectural blueprints, these security paradigms, and these deployment strategies and use them to orchestrate your own environments. Until next time, keep your hosts connected, and seriously, never forget to assign your licenses.